Hey, students. Hey, got a couple questions here about the harder one here, number 40, from really Projectile Motion, Chapter 3 of our main book, our college book, but it's assigned from the harder book here. And I see why this is a challenging problem here. And I wanted to address something. Actually, and the same thing comes up in, let's see, number 100 with the football player. So, want to be give you a little hint towards that. So let me start with a picture here. It says a basketball player shoots towards the basket, which is 6.1 meters away and 3 meters above the floor. If the ball is released 1.8 meters above the floor at an angle of 60 degrees above the horizontal, what must be the initial speed be if it were to go through the basket? All right, so when we draw the picture so we can help with our thinking, I'll draw the floor here. The basketball then is being released, as it says, 1.8 meters above the floor. Now, this alone brings up an important question, and that is, do you want to pick the origin to be where the basketball is released, or do you want to pick it from the floor? Now, I'll let you think about that for a moment. But then if I were to draw the basketball hoop and a backboard and then a pole that's holding up the backboard, this hoop is 3 meters above the floor. So everything's measured above the floor. That makes me kind of lean towards making the ground the zero of the vertical, but it would work from the basketball too, or any other spot. But just by the way it's kind of described, I'm kind of guessing kind of a natural reaction for most of you is to put the origin right under the basketball as it's being launched. And as I said in some other ones, it doesn't really matter where you put it, just make a conscious effort so you realize where you put it. And of course, since we're doing projectile motion, we're going to then split our paper into two pieces, X and Y. And so when we talk about the initial height, we're looking at 1.8 on the vertical axis and 0 on the horizontal axis if we use that as the origin. And of course, then the other thing here is the final position in the Y is then 3 meters if you measure things from the floor. And that's what makes it nice over here about measuring from the floor. If I measured from here, then I'd have to subtract the 2, but it would just come out to be 1.2. And then you can see when I begin to write out this first equation, y equals 2y naught plus initial speed in the y, t plus 1/2 ayt squared, you're going to put here 3 meters and over here 1.8 meters, blah, 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 blah. And I'll do the stuff in between in a second, but I just wanted to point out that if you did call the origin where the basketball is released, this would now be 0 and this would be 1.2. And that's the same number once I move this over and subtract it. So that's why it really doesn't matter. It has to do with the change in height, which is the 1.2. And so whether it starts at 0 and goes to 1.2 or starts at 1.8 and goes to 3, it doesn't matter. It's still an increase of 1.2. So no matter where you put the origin, it's still going to be an increase of 1.2. Now, that's probably more obvious than the main thing I want to point out. The main thing I want to point out, and maybe I'll go into a blue color here, is that there is a horizontal distance and a vertical distance, and therefore an angle that's straight to the basket. That is not the 60 degrees that they're talking about. The basketball is shot upward. It's going to arch over and go in to the basket. This is the 60 degrees. They make it very clear. It says here, the angle what does it say? If the ball is released 1.8 meters above the floor at an angle of 60 degrees. So this is the angle of the velocity vector. And maybe if I can find another color, maybe in black here, there would be a horizontal speed and a vertical speed. So what I'm trying to say here is we have two different angles associated with our two different vectors. One is the vector of position. How far is the ball from the hoop? The other one is a triangle or a vector that's the velocity. And they are not the same angles. They are not the same numbers. And so they're easy to mix. And that's where I want to warn you, because I need this number. I need the initial velocity in the y direction, as well as the initial velocity in the x direction. And maybe I should work up to that, but I'll keep filling in what we do know. They are saying that the basketball is going to travel, and I didn't put it in my diagram here, but they did say the horizontal distance is 6.1 meters. Shoots towards the basket 6.1 meters away. And so that's the final horizontal position. And they indirectly told me the acceleration, both x and y, because they are explaining this as a projectile. So 0 acceleration in the x and some in the y. So again, when I write out this equation, x equals to x naught plus initial velocity x time plus 1/2 a x t squared, and I put in my numbers for x, 6.1 and 0. And let me pause right there like I did in the y direction. Now I can get these initial velocities. So coming back to this triangle here, the velocity in the x direction is v naught cosine of 60 degrees, and v naught y, is v naught times sine of 60 degrees. So putting that information into here, I would go v naught cosine of 60 degrees times time and then plus 0. And if it helps, I'll put a v naught, and cosine of 60 degrees is 1/2. Moving the 2 over to here, we're looking at 12.2 equals to v naught t. And I'll put a little circle around that then, okay? And then doing the same logic over here in the y direction. Oh, and I'll pause because this now that I recall that I'm going to be using the 60 degrees, not the angle of the position, which I would have to work it out anyway. So maybe that helps in the problem that they only gave you the angle of velocity, so you wouldn't be tempted to do the angle of position. But as some of you had asked a question, I can tell you're doing the angle of position, not the angle of velocity. So that's why I thought it would make a good video here. But at this point, now it's just like the other ones I've shown you, where you're just going to go ahead and, fill in what you know, and you're going to have 2 equations and 2 unknowns. All right, so let me go with the y here. So this would be v naught sine of 60 degrees. Multiplied by time, and then minus 4.9 t squared. And then maybe I'll move the 1.8 over to here like we talked about before, so 1.2. Maybe I'll grab my calculator. Well, I guess I don't need a calculator for that. 1.866 for the sine of 60. And then, of course, let me also put then the v naughts. But then the time, let me then think of this as moving the v naught over to here. In fact, maybe I'll write it time equals 12.2 over V naught. So this becomes 12.2 over V naught. And you can see how helpful that's going to be now, because V naught is going to cancel with V naught, and you just have a number here. And also very helpful here, because this would be 12.2 over V naught squared. Oh, and squared. I should just put a square out there. That's what I meant to do. All right, so it's 12.2 over V naught, and then you square it. All right, well, let me simplify a little bit. Maybe starting with this idea, this number here. I already got the 0.866 in my calculator, so when I multiply it by 12.2, I'll get this 10.56. When I bring it to the other side, then it becomes 1.2 minus that last answer. So this is all a negative 9.3, I'll call it 66 here. And then this is a negative, and I'll put all the numbers together, 4.9 and then 12.2 squared. That is 729.3, and then V naught squared. Again, canceling the two negatives, and then moving the V naught to the other, or V naught squared to the other side, and then moving the 9.36 to this side. I mean, I would take this number here and divide it by the 9.366. And so that would be V naught squared, 77.868. And then finally, taking the square roots, I can get 8.82 meters per second for the initial speed. And I think that's what we wanted. What must be the initial speed if it were to go through the basket? Yep. All right. Hope that helps. Bye now.